Every second, the modern world relies on a massive volume of invisible exchanges. Financial markets clear trades, hospitals update patient records, and supply chains track cargo without a human ever pressing a button. Before software, the speed of the global market was capped by physical paper and human voices. As we shifted those records to tape drives and mainframes, machines took over the heavy lifting, removing the human communication bottleneck entirely. Today, the physical trading floor is effectively gone. It has been replaced by a digital environment where software talks directly to other software. The sheer efficiency of modern society relies entirely on how seamlessly these machines can pass information to one another. The bridge making that data transfer possible is the Application Programming Interface, or API. APIs are strictly deterministic. They require exact, pre-programmed instructions to function. Software A sends a specifically formatted request, and software B returns a predictable response. For a human developer, establishing that connection requires reading documentation and manually writing custom code to handle every single exchange. This manual process scales poorly. When integrating with the payment processor, email sender, and database, complexity multiplies. Every line is custom code. If a single API updates, the connection breaks, and a human must rewrite the logic. For predictable programs, APIs work flawlessly, but when an environment requires absolute flexibility, manual integration becomes an unscalable bottleneck. Large language models operate probabilistically. They reason, plan, and adapt, which directly clashes with the rigid expectations of a deterministic API. Even with the reasoning power to execute a task, an AI reaches a dead end when it encounters a traditional API. It simply has no way of seeing which endpoints exist or what specific parameters are required to trigger them. The current workaround is brute force. Developers load entire API schemas into the model's limited context window just to teach it a tool. This consumes massive tokens, causes severe latency, and routinely results in execution errors. When humans go to a restaurant, they look at a simple menu to order. Right now, we are forcing AI to ingest the entire kitchen inventory system just to ask for a coffee. Traditional API infrastructure is failing the way we build AI. The models have evolved, but the communication protocol hasn't. Anthropic's Model Context Protocol, or MCP, is a universal translator designed to bridge AI models and external data. Instead of relying on hard-coded instructions, MCP inverts the process. An AI connects to an MCP server and dynamically asks, "What can you do?" The server responds with a machine-readable menu of its available tools and data schemas. With this context, the AI can independently reason about the task, select the right tools, and sequence them together to achieve the user's goal. The tangled web of custom integrations vanishes. The developer builds one standardized MCP interface, and any compatible AI can instantly read it. This does not replace traditional APIs. It simply acts as a smart orchestration layer sitting directly on top of them. MCP removes the integration bottleneck. A single AI agent can now wield thousands of tools without a developer writing a single custom wrapper. But scaling up introduces a new threshold. Even with an MCP server, a single AI agent will easily become overwhelmed when tasked with a massive multivariable workflow. Google's agent-to-agent protocol, or A2A, shifts the framework from an AI using tools to an AI collaborating with other AIs. It relies on a process called agent discovery. Through standardized configuration files, agents broadcast their specialized capabilities to the wider network. A central planning agent receives a complex prompt, scans the grid, and locates subagents, one dedicated entirely to pricing flights, and another focused strictly on booking hotels. These specialized agents pass data back and forth, negotiate parameters autonomously, and execute their specific roles to fulfill the overarching request. By distributing cognitive load across a network of specialized intelligences, A2A removes the single agent capability bottleneck. We are watching the architecture of a new internet stack take shape. At the foundation are traditional APIs, the digital plumbing where programmatic work occurs. Above that sits the Model Context Protocol, adapters allowing AI models to operate that plumbing on the fly. Finally, the agent-to-agent protocol allows multiple AIs to coordinate across the ecosystem. Human beings are no longer the manual operators of software. We are becoming the directors of a globally connected, autonomous, and collaborative intelligent ecosystem.